Hello guys, welcome to DSA Bootcamp Day 34. Today we are going to study about graphs, and the problem we are going to solve today is lead code problem number 207, course schedule. So let's move on to the problem. So in the problem we have given a parameter number of courses. Number of courses starts from 0 to number of courses minus 1. That means if there are 5, number of courses is equal to 5. So the course will begin from 0 and end at 4. So the condition for solving this problem is that we must finish all the courses or complete all the courses. And for completion of course A, we require to complete the course B, which is a prerequisite course of A. So, in order to complete A, we must complete B. Here, there is an example given. So, in order to complete the course 0, we need to complete course 1. And if we can complete all the courses in the given list, then we return true. Even if there is one course that we cannot complete, then we return false. So let's move on to another example where we can understand this problem better. So for example, if there is a list given such like this, so the first course is course 0 and the prerequisite for course 0 is course 1. So we will map it in a graph such that the course 0 is directed to 1. मतलब यहाँ पे किस्सा है कि अगर हमें कोर्स 0 कंप्लीट करना है तो हमें पहले कोर्स 1 कंप्लीट करना पड़ेगा. सो हम लोग क्या करेंगे, ये प्रॉब्लम के लिए एक डेटा स्ट्रक्चर यूज़ करेंगे, ग्राफ्स और एडजेसेंसी लिस्ट. एडजेसेंसी लिस्ट में क्या होता है कि हम लोग एक वर्टेक्स के लिए उसके एजेस ढूंढते हैं और उसको कनेक्टेड बाकी वर्टाइसेस लिस्ट करते हैं. सो हम लोग के एडजेसेंसी लिस्ट का नाम होगा प्री मैप यानी प्री रिक्विजिट मैप. सो फर्स्ट वी विल इनिशियलाइज द प्री रिक्विजिट मैप with all the courses in it, starting from 0 to number of courses minus 1. And we will assign prerequisite lists for every course from 0 to 4. The list we will keep it empty at the stage of initialization. Then we will traverse the graph and add the prerequisites according to each course. So let's begin. So first of all, we will go from 0. So for course 0 to be completed, we need to complete course 1, which is the prerequisite for it. So now we will add course 1 in the prerequisite set for course 0. Then we will move on to the second element. Now for course 0, again course 2 is a prerequisite. So we will add that. Now next element is course 1. In order to complete course 1, we must complete course 3. So let's add 3. So for 1, there is another prerequisite 4. And for 3, there is another prerequisite 4. So now notice there is no prerequisite for course 2 and course 4. That means if we need to complete course 4, then it can be completed directly without any prerequisite. Now we are going to solve this by DFS method. That is, we will start from course 1. We will pass course 0 as the parameter. Then we will check its prerequisite. So course 0's prerequisite is 1. Then we will pass 1 as the course in the DFS. Like 1 will be passed to DFS function. Then we will check for 1. In order to complete 1, we must complete either 3 or 4. So we will first pass 3. Now the course in the DFS function is 3. So let's check for 3. For 3 to complete, we must complete course 4, which is prerequisite of 3. Now we will pass 4 as in as the parameter for DFS function. Now when we get 4, there are no prerequisites for 4. That means we can complete the course 4. Once we find such case where there are no prerequisites required, we return true to the function. So now 4 will return true. Now the callback will go to 3. Now since 3 prerequisite is 4 and 4 can be completed, again 3 will return true to 1. For 1 to be completed, we need to either complete 3 or 4. So since 3 can be completed, 1 can also be completed. So 1 will return true. Then it will go to 0 and 0 will return true. We need to check this same algorithm for every prerequisite and every course so that we do not miss any cases. Now, there is another case where a cycle exists for which we need to make a visit set. So now we will create a visit set. This means that if a course is added to visit set, that means we have already visited that course. So for example, here there is an example given in the lead code. So for course 1 to be completed, course 0 is its prerequisite. So in order to complete 1, we must complete 0. But to complete 0, there is a prerequisite 1. So it is impossible to complete any of the course as 1 is dependent on 0 and 0 is dependent on 1. So to detect such cycles, this is a cycle in the graph. 1 goes to 0, 0 goes to 1. So to detect such cycles, what we will do is we will add the 1 while traversing the first element 1. We will add it to the visit set. So now let's add 1 to the visit set. Now we are visiting 1. That means we are exploring 1, which means we are checking each prerequisite of 1 and finding if we can get an empty prerequisite set so that the course can be completed. Now, once prerequisite is 0, so now 0 will be passed in the DFS function, and now the 0 is our course. So for 0, let's search what are the prerequisites required. So for 0, the prerequisite is 1. We need to add 0 to the visit set because we are currently visiting 0. So now 0, in order to complete 0, 1 is required. So 1, but 1 is in the visit set, and in a set numbers cannot duplicate. That means we cannot add 1 again. So when a number is getting duplicated in a set, that means a cycle is present in the graph. So we need to check for this cycle using visit set. Now let's get to the code. First of all, we will create our pre-map function, that is this, where we have all the courses and prerequisites initially assigned to empty. So now we have created a dictionary kind of element, pre-map, where For each ith element, there is an empty list assigned to it. Like I is the key and the value stored is a list. Right now it is an empty list, and I ranges from number of courses. That is, I will range from 0 to number of courses minus 1, which are the actual number of courses which we have given from 0 to number of courses minus 1. Now let's fill in the values of each prerequisite for each course. So for courses, comma prerequisites, in the given parameter which is prerequisites, which is a list of lists. So now what we are doing here is, for each course and for each prerequisite of that course, we are appending the prerequisites to the course. That is what we did here. For the course 0, we searched what is its prerequisite. So zero's prerequisite is 1. So we added 1 to the list. Likewise, we are appending every time. So for course 0, the prerequisite also 2. So we will append 2 to the list. Now the pre-map structure is defined. Now let's define a visit set which will help us to detect cycles. So now we have initialized a visit set. Now let's get to the main part, the DFS function. And in that DFS function, we are going to pass courses as a parameter. Now, the first condition where we get that a course can be completed is when it doesn't have any prerequisites. For example, here in 4, course 4, it doesn't have any prerequisites. That means we can directly finish course 4. So, what is the base condition for this loop? What is the base condition for this recursion? Is that when the prerequisite list is empty, we can return true. True meaning we can complete that course. So, let's get with the base condition. If pre-map of course is equal to empty list, then we return true. Now, what is the another condition here? When there is cycle, we cannot return true. When there is a cycle, there is it is impossible to complete the courses. And how can we detect the cycle? By checking the visit set. If the element already exists in the visit set, then there is a cycle. So now let's add another base condition, that is, if course is in visit set, then we simply return false. Now, there can be a condition where neither of this is true. So, for example, the when we are checking in the visit list, the next element for 1 is going to be 3, which is not in the visit list, and also 3's prerequisites are not empty. That means both the conditions are not correct. Now we need to explore 3 and the next elements, which are the prerequisites of 3. So for that, we will first run we will first add that element to the visit set so that we can detect the cycle if that element is creating a cycle. So visit set dot add course. So now we have added that course to our visit set. Now we will run a for loop for the. Now what have we done here? For each prerequisite for a course, that is, for example, for course 1, each prerequisite, that is 3, then 4, will be passed to the DFS function as a course. So now 1 will pass 3 to the DFS function and check if it is true or if it is false. Now, if not DFS of pre, what does that mean? So, for example, here course 1 is now passing course 3 into the DFS function right here. Okay, so now instead of this 3 pre, we have given 3. Okay, so now the 3 will be run here and it will first check if course three's prerequisites are empty. If yes, then we will return true. But if there is a cycle related to course 3, then we will return false. Else, we will pass on the next prerequisite of 3, which is 4 from here. So now the recursion will go on, and when the recursion stops, we we should get a true response, because if there is a cycle or we cannot complete any course, then there is no point of checking any further. That is why we are checking if not DFS of pre, means if DFS of pre is not returning true, that means if DFS of pre, that is the course, is not returning true, which means it cannot be completed, then we directly return false. This will improve the time complexity. Now, once we have checked for all the prerequisites of one course, then recursively calling other courses, all the courses are checked. Now, once everything is done, we must remove that element from the visit set so that we don't mistakenly detect a cycle. That means if the 1 sticks here and 4 callbacks to 1, then there will be a cycle detected, even if there is no cycle here. So once one course is fully explored, that is, all its prerequisites are explored, we must remove it from the visit set. So now let's remove it from the visit set. Now, when we have done the traversal of 1 and it is returning true, then we can simply remove all of its prerequisites. So we can simply remove all of its prerequisites, as we know that 1 can be completed. So no need to check for other prerequisites, right? Even if we can complete one prerequisite, that means we can complete that course, and we just need to check if we can complete all the courses. There is no constraint that says we must complete all courses through all the prerequisites, right? So even if one prerequisite is also sufficient. So now let's empty the prerequisite set of one course which can be completed. So we will remove pre-map of that course. We will assign it to an empty list. So it will be better to compute. So computation time will reduce. Now we return true. Now there is, if we just keep it right here, then there is one test case that would get failed. The test case of disjoint graph. For example, there is a graph where in order to complete course 1, we must complete course 2, and in order to complete course 3, we must complete course 4. So we know that both the courses can be, all the four courses can be completed. So to complete course 1, we will take the prerequisite 2, and to complete course 3, we will take the prerequisite 4. But as you can see, these courses, this graph are disjoint. That means 1, 2 are related, but 2 and 3 or 2 and 4 are not related in any way. So we want, if we pass 1 as the starting parameter in the DFS, then we won't be able to get till 3 and 4, and we might return a wrong answer. So for example, if there is a cycle between 3 and 4, and we just check 1 and 2 and return true, then our answer would get wrong. So that's why we need to check for all the possibilities, that is all the courses. To check for all the courses, what we will do is pass all the courses to the DFS function. So for courses in range of number of courses, now here again we need to check if it is returning true, right? So if not DFS of course, then return false. Now, why again we are saying if not DFS of courses and not if DFS of course return true? So, the reason behind this is, if we do this, like if DFS of course return, then what would happen is that it will directly return true once there is a graph that returns true. For example, 1 and 2 would return true, right? So the function will get, so the function will return true here, which we do not want, as 3 and 4 won't get traversed. That's why we are saying if not DFS of course return false. That means here all the cases are being checked. And finally, when all the courses are passed, that is, if all the courses can be completed, we return true and we get out of the function. That was it. If there are any misunderstandings or doubts, please do ask. Thank you.